Now, what we have is a river is 120 meters wide, and it flows at 7 meters per second parallel to its straight bank. So the word parallel to its straight banks means I'm not doing one of those against upstream, downstream questions, okay? A speedboat can travel at 25 meters per second in still water. If the speedboat has to go straight across the river, find the angle at which the velocity relative to the river makes to the bank. So what angle does it go across and the time taken to cross the river? Okay, not too bad. So what we're going to do first is we're going to just do a quick diagram. Okay, so we're going to have is just our two banks here and here, and we know that it's going the velocity of the river, we call it VW or VR, whichever takes your fancy. I'll just call it VW still. Okay, so VW is 7 meters per second. Okay, and velocity. So we're going to travel this direction here to combat the river. Okay. Now you can go 15 meters 25 meters per second. Okay. So 25 is this way. What does your I component have to be to battle the current? 7 in the opposite direction. Okay. So you have a 7 here. And then we're going to have to do Pythagoras' theorem and figure out what this is. I'm guessing it's going to be 24, but we'll find out for sure. So we're going to say that, we'll call it x here. So it's x squared equals, not x squared. 25 squared equals 7 squared plus x squared. X squared therefore equals 25 squared minus 7 squared. Can somebody get 25 squared minus 7 squared square root the answer for me, please? What is it? 24. It is 24, is it? Perfect. Alright guys, 24. Any questions thus far on how we figured that out? He has to go straight across, so his I component has to cancel with the river. That's basically it. So we'll go straight across. So what we can now determine is that the velocity of the water is 7I. The velocity of the boat in the velocity of the boat in water, which is the direction you're taking in the water, is going to be you're going up and left, so you're going northwest. Northwest is minus 7I plus 24J. Is everybody happy with that? And once again, remember, velocity of boat in water is not taken into effect the current. Okay, so this is what you'd be doing in still water. You'd be just going up here in still water, but you're not in still water, you're in a current. So the actual velocity of if you remember your formula from yesterday, phi BW is phi B minus phi W. Therefore, phi B, the actual velocity of the boat that somebody on the bank will see. Somebody on the bank will see the boat going straight across. Okay? So your actual velocity of the boat is going to be phi BW plus phi W. So when you add them both together, so when you add this one here, this one here, and this one here together, what you get? Just 24J. Okay, so velocity of boat is 24J. So this means you're going to go 24 straight across. Now, I still haven't got the angle, have I? To get the angle, it's quite easy. Just call that angle B. Tan B is, we didn't even have, at the start of the question, at the start of the question we had 25 and 7, didn't we? You can use any angle function you want, but I suppose you should use the ones you're given at the start. So you have a choice. You can say that B is, we're so used to using tan. You could use tan inverse 7 over 24, or before you worked any of that out, you could have used sine inverse 7 over 25. So what's that angle when you work it out? Here we know. Huh? Anybody else? What did you say, 16 points? 26. Yeah, 16.26 probably sounds right. The adjacent is much longer than the opposite side. I'm going to very narrow angle, sounds right. Okay, now guys, we're now going 24 straight up, yeah? Every second. And the river we're trying to cross is 120. So time equals distance over speed. And what we're concentrating on is just basically it's going to be 120 divided by 24. And that will go 5 times. It takes 5 seconds. Okay, that's it. So it's not too bad.
Sir, for the angle there, I'm going for the other angle.
Oh, is it going for the angle which the velocity makes relative to the river with the bank? Alright, so the angle which the velocity makes relative to the river with the bank. So yeah, you're right. It's looking for this angle here. Okay, so it's looking for that angle there, just 90 minus that angle. And what you get? 90 minus 16.26. 83.74, right? 73. Oh, sorry, 73.74. Sorry, guys. According to the word of the law here, it's basically the angle which it makes angle which it makes with the bank is the key word. So it has to be lying in on the bank here, which is 73.74. Okay, guys. Okay, guys. So what we have is a small airplane has to fly 186 kilometers due east from Galway Airport to Dublin Airport. So we have here straight line going from Galway to Dublin. Due east 189 kilometers. Okay. Now, there's a wind blowing from the south. Now, what does from the south mean? It's going north. So, velocity of wind is going to be, what's a 60 J. Alright, no worries there. Now, the aeroplane can fly 100 kilometers per hour in still air. 100 kilometers in still air. So we know the magnitude of velocity of plane in air, still air, yeah? It's not the actual velocity of the plane, because the actual velocity of the plane is affected by the wind. So the velocity of the plane in air, the magnitude, there's no direction here, is there? It doesn't give us any direction it's going to fly in, because it has to combat the wind. See, the wind, if the wind is going north, you got to aim your plane this way so that it has to travel straight across. The actual velocity of the plane has to travel straight across. But in order for you to combat the wind, you have to aim diagonal down to combat the wind. You got that? Okay. So, that's what we're looking at there, okay? So we have to combat the wind, alright? So, find the time taken for the journey. Is the time taken for the return journey the same? Give a reason for your answer. Right, so here's what we can do with this one. What we can do is, we can, we're going to look at VPW, okay? So, the velocity of the wind, plane in wind, it's going to have to go 100 kilometers an hour down a certain direction. Can anybody tell me what does its J component have to be? 60. And what does it? We then can figure out the I component, can't we? Using Pythagoras' theorem. So Pythagoras' theorem will determine that this is going to be 80 when you do it. Okay, 8, 6, 10 triangle. Now, our velocity of our plane in wind now changes. We now understand that it's going to be 80I minus 60J. Then our velocity of our plane is going to be VW plus VPW. You add them both together. What happens when you add them both together? What you get? 80I. Okay, so in a nutshell, it's going 80 across, isn't it? So distance over time. Does it say anything about the angle? Just the time taken is what I want. So what's going to be is time is going to equal 189 divided by 80. Can I tell me what that is? 189 divided by 80?
2.4.
Is it 2.4? Yeah. On the dot?
No, 2.3625.
Alright, so 2.36, okay. Seconds. Now, guys, can anybody tell me, is the return journey going to be the same? Who can tell me if the return journey is going to be the same?
Yeah.
Alright, hands up if you think the return journey is going to be the same. Okay, now, you might have heard me yesterday talking about going up the river. Remember we said going up the river wasn't the same on the way up as it is the way back. Now, there's a reason for that. When you were going against the river, you're going directly against it on the way up. But on the way back, you're going with the river. In this question, the wind is perpendicular to your direction of motion. Therefore, it's symmetrical. On the way back, you're going to aim down at the same angle. So you're going to aim the same angle back downwards to combat the wind. If the wind was in any direction that had a component along the y-axis, that would be great. But because it's perpendicular, it has no effect on your actual speed. So if you work out your triangle on the way back, you're once again going to go down 60 to combat it. You're still going at 100. The only difference on the way back is you're going minus 80, aren't you? Because you're going 80 in the opposite direction. It's still the same distance over time. So therefore, both answers are going to be the same. So long story short, when your wind or your current is perpendicular to the direction you're going, the return journey is the same as the initial journey. It's only when your wind or your current is has a component that's opposite your motion, then it affects the time of the journey. Okay guys, that's an easy one to start off with, alright? So, this one here, he's caught in a current, swimmer's caught in a current which is flowing southwards at 1 meter per second. The resultant velocity of the swimmer is 2 meters per second in southeast direction. Find the speed of the swimmer relative to the current. Alright, now this is where language gets you. Okay? This is all about your English skills here. So, swimmer is caught in a current which flowing southwards at 1 meters per second. So, velocity of the river is minus 1J. Everybody happy with that? Now, if the resultant velocity of the swimmer, the actual velocity of the swimmer, do you understand? So the actual velocity of the swimmer is Vs. This is accounting the swimmer with the current. The current is accounted in this. So it's 2 meters per second in a southeast direction. What way southeast? This direction here. And he's going 2 meters per second, yeah? What angle is this? 45 degrees, yeah? So therefore we can put it into its two components. Its two components being, we call it x and y. So cos 45 equals x over 2. x equals 2 cos 45. 2 cos 45 is pretty sure it's root 2. So let me check that out for me.
Yeah.
And then the other one is sine 45 is y over 2. Y equals 2 sine 45. Once again, the resultant being root 2. Therefore, phi s is going root 2 down and root 2 across. So it's going to be root 2 across is root 2i, and root 2 down minus root 2j. Okay. Any questions on that one? Alright. Next. It's all about find the speed of the swimmer relative to the current, correct to 2 decimal places. Can anybody tell me the difference between speed and velocity? Anybody tell me the difference between speed and velocity?
Velocity has direction.
Velocity has direction, okay? So an example would be, if I had this here, if I had this vector here, very basic one, 3i going right, 4j going down. The velocity is 3i minus 4j. However, the speed is working out the hypotenuse. So therefore the speed is basically 5. So we have to take this knowledge into our answer, okay? So what we're going to have here is okay. So velocity of swimmer in the river. You never use VRS. The velocity of the river in the swimmer doesn't make sense. So the velocity of the swimmer in the river is what makes sense, okay? So that equals Vs minus Vr. Therefore, the whole question is about finding VSR. What can you do in the river on your own relative to the current? So what we're going to get here is root 2i minus root 2j, and then it's going to be minus 1j. Then when you break up your components, you're going to have root 2i plus, what's it going to be, 1 minus root 2j. We can turn 1 minus, that's on the outside. We can turn 1 minus root 2j into a decimal. Can somebody tell me what 1 minus root 2 is? I think it's going to be like something like minus 0.414 or something like that.
Yeah, exactly.
What?
Exactly.
Okay. So, minus 0.414 minus 0.414j. Okay? So, what I'd like to do here is, as I said before, we're going to do Pythagoras on this. And what we're going to get is root 2 here, 0.414 here. Square both of them and tell me what the speed is. So x squared equals root 2 squared plus 0.414 squared. And what do we get? Add them together, square root the answer. What do we get? I'm going for 1.47?
Yeah.
Alright.